A very pleasant morning to you, my dear children. Today we are going to discuss the properties of ionic compounds. Okay, so I have written some properties on the board. What are they? Physical state, melting and boiling points, solubility, conduction of electricity. So before going to these properties, let us try to recollect what is a ionic compound, right? So we know that when a metal and a non-metal react each other, the metal will lose electrons and becomes positively charged ion, and the non-metal will gain electrons and becomes negatively charged ion, isn't it? For example, in the case of sodium chloride, okay, sodium chloride, we know that sodium loses one electron, okay, and becomes cation. Positively charged ions are called cations, okay, and chlorine will become negatively charged ion, chloride ion, and which is called anion. So negative ion is called anion. Remember these two terms, okay, cation and anion. So due to the force of attraction between them, we know that opposite charges are they, isn't it? Cation and anions are oppositely charged ions. So we know that the opposite charges will attract each other very strongly, isn't it? So the force of attraction between this cation and anion will be very strong. So in each and every ionic compound, we know that the force of attraction between the positively charged ion and the negatively charged ion will be very strong. First, you keep that point in your mind. Okay, the force of attraction between these ions is very strong. Okay, so now let's move to the properties. Okay, so the first property is physical state. Okay, what are the physical state of ionic compounds? So we know that usually when the force of attraction between the particles is too strong, what will happen? They will be too closer to each other, isn't it? So what state they will be? They will be in solid state, isn't it? So due to the high force of attraction, okay, the ionic compounds are usually in solid state, and also they are hard solids. They are hard in nature because of the strong force of attraction between this positive and negative ions. Is that clear to you? Alright. We will move to the second one, melting and boiling points. What is melting point and boiling point? We know that melting point is the temperature at which a solid melts into a liquid. Boiling point is the temperature, the fixed temperature at which a liquid becomes vapor. Isn't it? Okay. Now, keep in your mind or taking from your mind that ionic compounds are having strong force of attraction, isn't it? So, to weaken the strong force of attraction, we have to provide high amount of energy. What is, when a solid melts, what happens there? The force of attraction the particles become weaker, isn't it? Then only they will start to move away from each other, isn't it? So you have to provide a lot of heat energy to overcome this strong force of attraction between the ions. So melting point and boiling points of ionic compounds are very high. Okay, so they have very high boiling and melting points because they have a very strong force of attraction between these ions. Okay, and the third one, solubility. Okay, so solubility, they are highly soluble in water. Highly soluble in water. Okay, soluble in water. But other solvents like kerosene and alcohol, etc., they are not soluble. Okay, they are not soluble in other solvents like kerosene, alcohol, etc. But they are highly soluble in water. Is that clear? Okay, now move to the fourth property, conduction of electricity. We need to draw a diagram. So, we are going to draw the diagram and explain. Okay? Okay, the fourth property is conduction of electricity. Generally, in solid state, we know that conduction of electricity is not possible. Why? Because conduction of electricity involves the movement of ions. If the free movements of ions are not there, electricity cannot pass through the substance, right? So, in solid state, ionic compounds are having no free ions, isn't it? Therefore, they do not conduct electricity in solid state. But when they are in molten state, okay, or in when they are dissolved in solution, two states are there. Number one, molten state, okay, and when they are dissolved in, the ionic compounds are dissolved in water, okay. So when that means solution, okay. So what happens to the ions? Free ions will become possible. The movement of free ions will start to occur even in molten or also in dissolved state, okay. Therefore, free ions are available there. That is why conduction of electricity become possible, okay. So, in ionic compounds, molten state and when they are in solution, and then only they can conduct electricity, okay. They cannot conduct electricity in solid state. So, to prove that one, they are conductors. We have an experiment here. So, here you can see salt solution is taken in a container, salt solution, and two graphite rods. What is the speciality of graphite? Graphite is a form of carbon, right? They can conduct electricity. They are very good conductors. So, two graphite rods are taken. One is connected to the positive terminal of battery. That is why it became anode, positive electrode. This became positively charged. Positive electrode. Positive electrode is called anode. Okay. And this is connected to the negative terminal of battery. Therefore, this became negatively charged, and the negatively charged electrode is called cathode. Don't forget. Okay. Cathode is negatively charged. Anode is positively charged. Before, we have discussed two terms, cations and anions. Okay. So, that also we will combine together, and don't forget that points. So, negative electrode is called cathode. Just keep this one in your mind. Negative electrode is called cathode. Only you remember that point. Then all other things will come into your mind. So, positive electrode. What is positive electrode? Okay, anode, right? Okay. Now, the ions which move to cathode are called cations. What are cations? The ions move towards cations are the ions move towards cathode. So, cathode is in negative charge. So, what will be the charge of cations? Definitely positive charge. Opposite charges only can interact each other, isn't it? And also the ions which move to anode is called anions. What are anions? The name is derived. Why? Because they are moving to anode. So, anode is positively charged. So, what is the charge of anion? Negative. Clear? So, only keep in your mind this one. Then everything will come into your mind automatically. What is that? Negative electrode is cathode. Negative electrode is cathode. Positive electrode, anode. Then the ions moving to cathode is called cations. They are called cations because they are moving towards cathode. So, what is the charge of cathode? Opposite, positive. And the ions which are moving towards anode is called anions, and here negative charge. Okay. So, here anions are negatively charged ions and they will move towards anode. Clear? Okay. We'll come back here. So cathode and anode, hope you understood. Cathode is negatively charged and anode is positively charged. Okay. And a bulb is connected here. This is a bulb and this is a switch. And when the switch is on, what will happen? If the electricity is passing through this one, the bulb will lit, isn't it? Okay. So in salt solution, a lot of ions are available because they are in solution state. Okay. So what will happen when the switch is on? The bulb will lit because of the free movement of ions through the circuit. Electricity will pass. Okay. So conduction of electricity is possible in molten state and also in solutions. Okay, they do not conduct electricity when they are in solid state. Hope it is very clear to you. Now we will move to the discussion of page number 49 questions. Okay, so here is page number 49. Question number 1, write the electron dot structures for sodium, oxygen and magnesium. You have to draw only the atoms, okay? Number 1, sodium, 2, oxygen and magnesium. Let's try to draw sodium. What are they? First one, sodium, then oxygen, and the third one, magnesium. You know already. Okay. Alright, sodium, atomic number 11, electronic configuration 281, right? So here is this is nucleus, 2 electrons, second shell, how many electrons? 8 electrons are there, 3, 4, 5, 6, 7 and 8, and in the last shell 1 electron. Okay, so this is sodium atom. Okay, what is the second one? Oxygen. How to draw oxygen? Oxygen atomic number 8, 2, 6. Okay, very simple. Nucleus, first one and second one. First shell, K shell, 2 electrons. Second shell, L shell, okay, 6 electrons are there. Yes, this is oxygen atom. And in the same way, hope you can draw magnesium atom, atomic number 12, so the electronic configuration 282. Okay. Okay, first question, second part. Show the formation of sodium oxide and magnesium oxide by the transfer of electrons. So in that case, you have to draw the ionic bonding. Okay, ionic bonding in sodium oxide and magnesium oxide. Okay, hope you understood that very clearly. Okay, so I'm not going to draw that one because we already discussed the magnesium oxide and sodium oxide. I have given you as a home assignment. Alright. So the third question, what are the ions present in these compounds? Okay, in sodium oxide, what are the in sodium oxide? What are the ions present? 2 different types of ions are present. One is Na plus, isn't it? And oxygen 2 minus ions are produced when sodium oxide is formed, isn't it? Or by the formation of these 2 ions, the ionic compound sodium oxide is formed. Clear? So Na plus and oxygen 2 minus. 2 sodium atoms are there. So if you want, you can write 2 Na plus and 1 oxygen 2 minus ion. Okay. Sodium, a positive ion, 2 ions are forming and 1 oxide ion is also formed. What about magnesium oxide? In magnesium oxide, 1 magnesium 2 plus ion and 1 magnesium 2 minus ions are formed. Okay. 1 magnesium 2 plus and 1 oxide 2 minus ions are formed during the formation of magnesium oxide. Okay, and second question, why do ionic compounds have high melting point? Why they are having high melting point, just now we discussed. Because of the strong inter-ionic force of attraction, or you can say because of the strong force of attraction between the oppositely charged ions. Okay, to overcome this force of attraction, high heat energies should be provided. Okay, therefore they are having high melting point, also high boiling points. There is a table, melting point and boiling point is given in this table, page number 48. For example, one example I will tell you, sodium chloride is having a melting point 1074 Kelvin, okay, not Celsius, 1074 Kelvin, okay, and boiling point of sodium chloride is 1686 Kelvin. You don't have to by heart all this. Just I told you that much high temperature is required to break that inter-ionic bonding, because they are very strong force of attraction between these ions. Okay, hope it is very clear to you the properties of ionic compounds. Alright, so the portions, extraction of metals, refining, corrosion, etc. are avoided this year. You don't want to study. So the next one is last exercise, page number 56. Okay, the exercises, except the omitted portion, from the omitted portion, all the questions we will discuss through PowerPoint presentation in the coming class. Alright, hope it's very clear to you. Thank you and have a nice day.